What if your AI could do more than just calculate? What if it could feel its way through a really complex problem? We're not talking about simple algorithms here. Imagine an AI that has something like a gut feeling, an instinct to get things done. Well, that's exactly what we're going to dive into today. How we're building that kind of instinct into AI agents.
Because that's really the heart of it, right? It's the big question that takes us from an AI that just knows a bunch of stuff to an AI that can actually go out and perform actions for you.
So here's the fundamental difference. A standard large language model, an LLM, it's kind of like a super intelligent encyclopedia. It's been trained on a massive but totally static set of data. An AI agent, on the other hand, it uses that LLM as its brain, but then it connects that brain to the real world. It can interact, it can make decisions, and it can complete tasks all on its own.
So here's our game plan. First, we're going to look beyond the chatbot. Then, we'll unpack the agent's toolkit. After that, we'll see one in action, separate the hype from reality, and wrap up with a practical blueprint for anyone looking to build one.
All right, so let's start with a kind of AI most of us are familiar with and really pinpoint what its biggest limitation is.
So you've got tools like ChatGPT, right? They're powered by what's called generative AI, and they are fantastic at creating new text, images, or even code based on all the patterns they learned from their training data. But that's also their biggest weakness.
And that weakness has a name: the knowledge cutoff. An LLM's entire world is basically frozen in time. It can't tell you who won the game last night or what the price of a flight is right now, because that information is brand new. And if you try to push it, it might just make something up. That's what we call a hallucination.
And this is exactly where the AI agent comes into play. You can think of it as a program that uses an LLM as its brain to think and reason, but then it takes that critical next step. It can autonomously perform tasks, make its own decisions, and interact with the world to achieve a goal. It's not just a thinker, you see, it's a doer.
So how does it do all this? What's the secret sauce? Well, it all comes down to 4 core capabilities that make an agent, well, an agent.
And what's so cool about this is how much it mirrors the way we humans solve problems. First, it can plan. It takes a big, complicated goal and breaks it down into a simple to-do list. Second, it can use tools. These are like its hands. It can browse the web, talk to databases, use other software through APIs. Third, it can remember, tapping into both short-term memory from a conversation and long-term knowledge from specialized data. And finally, it can execute. It actually takes action, like sending an email or running a piece of software.
Okay, theory is great, but let's see this in action. I want to show you a concrete example. How could an agent take a simple link to a news article and turn it into a shareable meme completely on its own?
The goal here is simple, but it's really powerful. All you do is email the agent a link to a news article. That's it. Your job is done. The agent handles every single thing from there.
And this just lays out the whole process beautifully. The agent gets the email, it parses it to find the URL, and then it scrapes the full text to the article. Then its LLM brain kicks in to plan a meme. It figures out the top text, the bottom text, all in a nice structured format. Then it uses a tool, an image generation API, to actually create the meme. It uses another tool to host the image online to get a shareable link. And finally, it executes that last step by emailing the finished meme right back to you. Zero human intervention needed. Pretty amazing.
Okay, that seems like magic, right? But now we need a really important reality check. It's time to pull back the curtain and separate the social media hype from the actual engineering that makes these things reliable.
This quote from developer Dave Ebelar just nails it. The most effective AI agents aren't actually that agentic at all. They're mostly deterministic software with strategic LLM calls. That single idea is a total game changer for how you should think about this.
So the hype you see online, it's often this idea of just giving an LLM a goal, a box of tools, and then just hoping for the best. That approach is super unpredictable, and frankly, it's risky. The reality of building systems that actually work is to use reliable, predictable code for the main workflow, and you only bring in the LLM for the very specific parts that require reasoning. See, making an LLM call is the most expensive and dangerous part of the whole process, so you have to use it surgically.
So if it's not about these magical, all-powerful frameworks, what is it about? Well, it comes down to a blueprint made of foundational software engineering principles.
And here they are. These are the 7 building blocks that make up the real toolkit.
You've got your intelligence, that's the LLM call, you need memory to keep track of context, and tools to connect to APIs. But then comes the really critical stuff: validation to force the output to be predictable, control using simple if-then logic to decide what to do next, and recovery for just standard error handling when things go wrong. And finally, feedback, that crucial human in the loop for important approvals. See, this isn't magic at all. It's just solid, smart engineering.
And that brings us to the main takeaway. Building powerful, reliable AI agents, it isn't about chasing the newest, hottest framework on Twitter. It's really about applying these proven, foundational software engineering practices to this incredible new technology.
Which kind of leaves us with one last thought to chew on. As these AI systems get more and more woven into our lives, maybe the secret to unlocking the future of AI isn't some mystical new discovery, but simply applying the discipline of really, really good software engineering. What do you think?